Hello everyone, welcome to our third video series in our subject. We have now group data. Anderson et al. 2015 discusses about group data. In most cases, measures of location and variability are computed using the individual data values. Sometimes, however, data are available only in a group or frequency distribution form. In the following discussion, we show how the weighted mean formula can be used to obtain approximation of the mean, variance, and standard deviation of the group data. So this is the table. We have the audit time. That's 10 to 14 days. There are frequency of 4, for 15 to 19, 8, 20 to 24, 5, 25 to 29, 2, 30 to 34, 1, with a total of 20 frequency. To compute the mean using only the group data, we treat the midpoint of each class as being representative of the items in the class. So let M sub I, we let M sub I denote the midpoint for class I, and let Fi denote the frequency of the class I. The weighted mean formula is then used with the data values denoted as Mi and the weights given by the frequencies Fi. In this case, the denominator of the equation 17 is the sum of the frequencies, which is the sample size n. That is, a summation of frequency I equals n. Thus, the equation of the sample mean for group data is as follows. So this is the formula: summation of frequency I, midpoint I, divided by n. That is, our Mi is the midpoint of the class I, Fi is the frequency for the class I, and n is the sample size. With the class midpoints, Mi halfway between the class limits, the first class of 10 to 14 in table 21 has a midpoint at 10. You're going to add 10 plus 14 divided by 2. That would be 12. The 5 class midpoints and the weighted mean computation for the audit time data are summarized in table 22. As can be seen, the sample mean audit time is 19 days. So to compute the variance for group data, we use a slightly altered version of the formula for the variance. We trace the class midpoint Mi as being representative of the Xi values in the corresponding class. Thus, the squared deviations about the sample mean X sub I minus the mean squared are replaced by Mi minus the mean squared. Then, just as we did with the sample mean calculations for group data, we weigh each value with the frequency of the class Fi. The sum of the square divisions about the mean for all the data is approximated by the summation of the frequency M sub frequency I times the Mi minus the mean squared. The term n minus 1 rather than n appears in the denominator in order to make the sample variance the estimate of the population variance. Thus, the following formula is used to obtain the sample variance for group data. This one, S sample variance, summation of Fi times Mi minus the mean of x squared divided by n minus 1. So, you will have this table. So this is the given. So we already compute for the class midpoint 12, 17. So you add 10 plus 14 divided by 2, that is 12. 15 plus 19 divided by 2, that is 17. 20 plus 24 divided by 2, that's 22. 25 plus 29 divided by this 27. 30 plus 34 divided by 2 equals 32. And the frequency is given 4, 8, 5, 2, 1, total of 20, no? And then we multiply this one, 12 times 4, that's 48. 17 times 8, 136. 22 times 5, 110. 27 times 2, 54. 32 times 1, 32. You add this up, that's 380. So to compute for the sample mean, 380 divided by 20. So that is equivalent to 19 days. So I hope you know how to compute that, no? Then for the computation of the sample variance, we have this table. So this is already given, the audit time. You know already how to compute the class midpoint. you just simply add the 10 and 14 and you divide it by 2, so you got 12, 17, 22, 27, and 32. The frequency is given. Then you will now compute for the deviation. Mi minus x, so mi is 12 minus 19. 12 minus 19. 19 is our sample mean. 12 minus 19, so that is negative 7. 17 minus 19, that is negative 2. 22 minus 19, that is 3. 27 minus 19 equals 8. 32 minus 19 is 13. So if you add this up, so that's the division. That's the division. Okay, and then square division, we multiply negative 7 times negative 7, that's 49. Negative 2 times negative 2 equals 4. 3 times 3 equals 9. 8 times 8 is 64. 13 is 169. And then we multiply now the mi, this one, 12 times 49. 12 times 49, that's 196. 8 times 4 equals 32. 5 times 9 equals 45. 2 times 64, 128. 1 times 169, 169. Add this up, this is 570. And the formula for our sample variance would be s squared equals fi n minus 1. So that's 20 minus 1 is 19. 570 divided by 19, that is 30. So the calculation of sample variance for audit times based on the group data is on table 3.3. The sample variance is 30. So the standard deviation for group data is simply the square root of the variance for group data. For the audit data, the sample standard deviation is s equals the square root of 30, which is 5.38. So square root of 30, that is your standard deviation, and that is 5.48. And I guess we're done. Yes, we're done with our topic. So I want you to solve right now. You will be given the I'll give you the frequency, a different frequency for your activity now. You will be given with a number like this one. Just this will be your given. I'll give you something like that, and you will compute for the standard deviation, the sample variance, the sample mean. Okay, for your problem set now, so you will be given this one, the audit time 10 to 14, 15 to 19, 20 to 24, 25 to 29, and 30 to 34, with the frequencies 62255. So that is total of still 20 frequencies. So we're gonna compute now. I'll give you, kindly pause the video, and later on I'm going to give you the solution. Okay, so first we are going to compute for the sample mean. So to compute for the sample mean, we need to have this table. This is our sample mean. Okay, so first is when we are going to look at the class midpoint. For 10 to 14, the midpoint is 12. 15, 19, that is 17. 22, 27, and 32. So these are the class midpoint, guys. What you did here is you add 10 plus 14 divided by 2, 15 plus 19 divided by 2, 20 plus 24 divided by 2, 25 plus 29 divided by 2, and 30 plus 34 divided by 2. So you have now the class midpoint. After that, you're going to copy the frequency 6, 2, 2, 5, 5. Okay, then for if I am I, you need to multiply this one with this value. So you got 72, and you can drag this one. You can compute, no? You can multiply that. Okay. And then after this, you're going to have the summation of these values, which is 445. And the sample mean, the formula for the sample mean, this is now the formula, summation of FIMNI divided by N, which is 20. So let's have that. So sample mean is equal to 445 divided by 20. Okay, so that's sample mean is 22.25. That is our sample mean. So you have to what you call that, save that number for our next solution. Okay, so in order to compute for our next problem, which is the sample variance, we're going to compute the sample variance and the standard deviation. We need to have this table, guys. You have the audit time, the class midpoint, the frequency, we already have that, and we have the deviation, which is mi, this one, the class midpoint, minus the sample mean, the value that we have. And this one is the square division, and this is the multiplication of the frequency and this one. Okay, so let's try to solve that with our here. So the deviation, mi minus, so this is mi, 12, so this is equals to 12 minus this one. I can put a dollar sign between c, so that would be fixed. So that's negative 10.25, and I gonna drag this down. I can drag this down so that I could have some answers. So these are the answer, negative for our deviation. That is 12 minus 22.5, so that's the value. This one, 17 minus 22.5, that's negative 5.25. 22 minus 22.5 is negative 25. 27 minus 22.25, 4.75. 32 minus 22.5, 9.75. For the square division, you just simply multiply this with this. So that is a positive 1025, and we are going to drag this one. These are the value, that's for the square division. And after that, we are going to multiply the multiply the fi with our answer here. So 630. Okay, there you go. And we are going to compute for the sum, the total of this one. So let's try to drag sum of G21 to G25. So that's 1273.75. So for our sample variance, is equal to this value divided by 19. Why 19? Because that's 20 minus 1. As you can see here, guys, 20 minus 1. Okay, so enter. So that's 67.04. That's our sample variance. And for our standard deviation is equal to the square root SQRT, the square root of this number. That is our standard deviation, which is 8.19. So I hope you have similar answer with me, and congratulations. Please do not forget to rate your score using our rubric PET. P for stands for performance, E for error free, and T for timeliness. Thank you very much for watching and see you next week. Bye everyone. Thank you very much.